All right, team, welcome back for part D. Now, let's take a look at this. Given that f of 1 is equal to 3, write an expression for f of x that involves an integral. Find f of 4 and f of negative 2. All right. So I made myself a new piece of paper. If you just need to draw a line and write part D, that would be fine. But this question asks a few things. It says, hey, we know that f of 1 is equal to 3. And we want to know what is f of 4 and what is f of negative 2. All right, a couple of things about this. The formula I like to use is final value equals the initial plus the change. Okay. We already know the initial. We just really have to figure out the change. So let's write what we do know. We know that f of x is going to equal 3 plus or minus however much it changes. A couple of things you need to know about some calculus. I'm sure you guys remember, hey, to get from f to f prime, you can use a derivative. That means to get from f prime back to f, you can use an integral or antiderivative. This means that f of x is equal to the integral or antiderivative of f prime of x dx. Okay? If I took the integral of f prime, I would end back up at f. So, since f of 1 is 3, the change is going to represent now I'm doing the change, is going to be the integral from 1 to whatever to x of f prime of x dx. Okay? I'm getting the 1 from up here. Oops. I'm getting the 1 from up here. So let's try this. Oh, and by the way, you guys just got a point for writing the integral expression. So let's try this. Let's do f of 4. Well, I keep my 3, that's my initial value, plus the integral from 1 to 4. I get my 4 from right here. That's how much it changes of f prime of x. Okay, leave yourself some room because we're going to come back to that. But let's try it with f of negative 2. Well, f of negative 2 is just going to be 3 plus the integral from 1 to negative 2 of f prime of x dx. Again, I get that upper bound from this number right here. And by the way, for doing both of these, you get a point. Now we just have to find the answers. So f of 4 is equal to 3 plus, this was off on how the heck do I do the integral from 1 to 4? Well, integral means, and hopefully you guys are shouting this in your computer, area. So let's go back to the question. It gives us a hint. The areas of the regions bound by the x-axis and the graph of f prime from negative 2 to 1 and 1 and 4 are 9 and 12 respectively. So it means this area right here, the area is 9, and then all this part in here the area is 12. Now, both of these are below the x-axis, so they're actually negative area, -9 and -12 units. So when I come back over here, the integral from 1 to 4, the integral from 1 to 4 is -12. It's right there. So this is 3 plus -12. I'm fine to leave it like that. You would get the point right here. You could also say f of 4 is equal to -9. But don't make a mistake. If you say 15 or +9, you just lost the point. This one's a little trickier. F of -2 is equal to 3 plus the integral from 1 to -2. Now, when we do integrals, you're usually used to reading it from left to right, -2 to 1. But the integral from 1 to -2 of f prime of x dx is going to be the negative value of the integral from -2 to 1 of f prime of x dx. And you guys might remember, oh, that's what happens when we try to do a backwards integral. You always read these left to right, and since this one is upside down, in order to flip it, we make it negative. So you could make this 3 plus negative integral from -2 to 1 of f prime of x dx. I think that's confusing, plus negative. This might be easier to think about as 3 minus the integral from -2 to 1 of f prime of x dx. Okay? So we go back to my chart. We're going from -2 to 1. The area from -2 to 1 is -9. So, and get this, we get 3 minus a -9 is f of -2. You're fine to leave it like that. Don't make a mistake. If you wind up with 6 or -6 or something, you just lost a point because f of -2 here would be equal to 12. And you get +1 for the answers. This one and this one. So that's a 3-point question. All right. Great job, team. Now what I'm going to do is I'm going to take a picture and upload it to Google Classroom. I'll make a separate video showing you that, but I still want you guys getting out your cell phones, taking the picture, and sending it to me.